This video is for Stat 110, Module 2, Part 5, and includes a discussion of how to obtain a p-value using a spreadsheet. This can be done in Google Sheets or in Excel, either one. Okay, let's go ahead then and get started. So the example that we're going to work with is going to be the WSU vitamin case study. And I'm going to use the mail information from the mails there. So we considered that previously in Module 2, Part 4. Our research question in Module 2, Part 4 was, is there enough statistical evidence to say that WSU males are off target from their daily recommended intake? This was a two-sided test, and the observed outcome that we had from this study was 3 out of the 14. So again, more information can be obtained if you look at Module 2, Part 4. Now, the reference distribution that we obtained, or the solution that I obtained, was one similar to this one here. And yours should have been similar to this one as well. So the p-value was close to the 0.05 threshold for this example. If we went ahead and made our decision, and our conclusion, we learned that we did not have enough evidence. At least I did not, because my p-value, which was 0.0572, did not quite meet that threshold of 0.05. Now, one thing that we don't want is somebody to say, well, they didn't really like the answer that they got here, so let me try a different simulation. Or maybe my p-value was 0.0572, but my colleague's p-value was maybe 0.493. So my colleague would get one answer for their research question, and I would get a slightly different answer for the research question. So I went ahead and ran a second one, and sure enough, the p-value actually got pretty close to that 0.05 threshold. So one way to prevent this is to use more than 5,000 outcomes. Certainly 5,000 is enough. It gives us a good idea of what's going on, but we do have some variation in one reference distribution compared to the next. So luckily, these two reference distributions ended up giving us the same conclusion. But as I said just a moment ago, we would hate for somebody to keep getting more and more reference distributions, just keep getting them until they get the answer that they want. So let me introduce the binomial probability model. The binomial probability model is going to prevent this from happening. Essentially, what the binomial probability model is the stuff that we've been doing, except I'm going to let the number of statistics that I use on the graph, or the number of repeated outcomes, to go on and on and on and on forever. So instead of using 5,000, we would just use an infinite number of dots, or an infinite number of repeated outcomes. Now certainly I cannot let my computer run forever, so this idea of a binomial probability model is a mathematical approach to obtaining this reference distribution. This is a very common probability model that we use in statistics. So a little bit about the binomial probability model. It has two possible outcomes, so it must have two possible outcomes. Often these are labeled as success and failure, and that's how our app was set up. Our app used labels success and failure. A second condition in using the binomial probability model is that there's a known and fixed number of trials. So in our study, there was 14 males that participated in this study. So that's known and fixed. Excuse me. Sometimes that quantity is not known for a particular situation or a particular investigation. For example, how many cars am I going to see, say, in 1 hour that go through a drive-through? of a fast food restaurant. That's not a fixed number. 1 hour that might be 8, the next hour it might be 12, the next hour, if it's right at dinner time, might be 30. We don't know how many are going to show up in that hour. So that would be a situation if you're trying to model how busy a drive-through was, a fast food restaurant drive-through lane, you wouldn't be able to use a binomial probability model because we don't have a fixed number of trials. That probability of success has to be the same from one trial to the next. So when I label that P, or I put that quantity in that P box on my simulation app, that same P quantity needs to be used for all of the simulations. And then the trials must be independent of one another. One trial can't influence the other. So where we might run into trouble on something like this is if 3 of these males that participated in our study were roommates. If they share the cooking duties, then one person's lack of vitamin A may be influencing another person's lack of vitamin A. So we need the individuals to be independent of one another. So here I am checking those conditions, okay, for our situation. The 2 outcomes, yep, I was either over or under. Fixed number of trials, yes, I had a total of 14 males. The probability of success, yes, that's going to be 50-50. Again, under a situation of being on target. So we got to remember, again, what situation we're building our reference distribution for. And then I'm going to assume that these trials were independent of one another. Now I called these conditions or assumptions, and these types of things should be verified before using the binomial probability model. I skipped over some of the syntax or the mathematical formula up here up above. This is what the probability formula looks like for a binomial probability model. Now we're not going to need to use this because we're going to use a spreadsheet to obtain our outcomes. Okay, so let's move on to how to get this done in a spreadsheet. The first thing I need to do in a spreadsheet is just create my number line. So for the WSU vitamin study, my number line went from 0 to 14. So I need to create my number line in my Excel sheet or in my Google sheet. So I'm just going to give it a name, number over here, or count of over, and I'm just going to list that out from 0 to 14. Now you can get that started, use like 0, 1, 2, and then in the lower right hand corner here, you can click that and drag it down and it will autofill down through 14 for you. The second step is to use the Binome Dist function. So the Binome Dist function needs to take 4 things, and I need to put commas between those. So again, in our cell B2 here, or the probability value for 0, this is what that formula is going to look like. Binome Dist, A2 just simply refers to my number line, the first quantity in my number line. 14 is my sample size, or my n quantity. My 0.50 is the pi value. Okay, that's the same thing that goes into the box when I'm using the simulation app. And then the last thing needs to be false here. What false is going to do is return the probability for that outcome. I need to carefully have commas between those, and I need a parentheses and an end parentheses when using any kind of function inside of a spreadsheet. So here's what that's going to look like in my spreadsheet. I'm going to type that in carefully, and then I'm going to, again, in the lower right-hand corner, click on the square and drag that down. I went ahead and made a video for you to show you how to do all of those steps. So down here, obviously the video was shown here. So I created a video, sorry about that, I created a video showing you how to get the binomial probability model in Google Sheets for this example. So this is it'll take a little bit to watch, but I encourage you to watch this before trying to do this on your own. All right, so let's go back up here and just continue. So this is what the binomial probability distribution is going to look like. I went ahead and created a graph. Again, that video down below will show you how to compute the graph. Here's some instructions on how to compute the graph, just kind of spelled out for you. And then we have our first question. So on the left here is the reference distribution that we got from the binomial simulation app, or the simulation app, the reference distribution. That looks familiar. And this is what it looks like from the binomial probability model. Now we call this an exact reference distribution because we know that this is exactly correct, because this is based on, again, an infinite number of outcomes. And those two distributions are going to look very, very similar. The expected here is clearly at 7. You can see that. It tends to go down from 7 in a very systematic way. 2 and 12 kind of look like where I'm starting to be an outlier on both of those distributions. So what we have been doing is a pretty close picture of what the probability model based on mathematics. So go ahead and answer question 1 there. I think I did that by just talking through there. Okay, the binomial probability model, when I get the value of 5 here, that's about 12%. So what does that mean in the context of this example? Well, if WSU males are on target, so again, that's how this reference distribution was built, then about 12% of the time, we will observe 5 males being over on their vitamin A intake. Or if we want to be real exact, 12.22. So again, this is when the reference distribution was built under on target. So we need to include that. That's going to happen about 12% of the time. If we do the p-value, if we're going to do p-value type stuff, I need to worry about the probability of 5 and the probability of 4, probability of 3 and 2 and 1 and 0. And then if it's two-sided, I got to worry about the probabilities on the other side as well. So we'll have more about that down below here. Here's what those here's what the formula would look like if I was interested in computing the probability for 5. Again, I don't want you to be scared by this because we're going to use this spreadsheet to do these calculations for us. So let's go there, getting the p-value. Again, here's my reference distribution, 0 to 14. Going to set this up under a 50-50 scenario. So again, when I'm building my reference distribution, I'm going to be using that 14 here, and I'm going to be using the 50-50 here. I need those quantities when I'm using that Binome Dist function. This is a two-tailed analysis. So when I'm worrying about values as extreme or more extreme than 3, I'm going to certainly go from 3 to 1, 0. I'm going to use the left side, but I'm also going to need to do the mirror image of 3 on this picture. This is a two-sided analysis, so I need to worry about the other side. 3 is 4 away from 7, so I need to jump up 4, which is going to be at 11. excuse me, so I need the probability values for 11, 12, 13, and 14 as well. We can call the p-value on the left side maybe p-value low, and the p-value on the right side is going to be p-value high. We're back to that video, so I will let you go ahead and hit pause here, and you can watch the video in the notes. So the p-value that we got in the notes was 5.74%. Again, that's given down here in the status bar in the lower right-hand corner. So we don't have to, we just need to highlight the cells that we need to compute the p-value, and the p-value is returned down here in the lower right-hand corner for me. To highlight these cells, I can highlight a set, and then I can hold down the control button, and then I go and highlight the other set for the p-value high. On a Mac, it's either going to be the Command button or the Apple button that will allow you to highlight two different sets of cells that are not next to one another, or two different sets of cells that are non-contiguous. It turns out that for a 50-50 scenario, the p-value low is going to match the p-value high exactly. So for a 50-50 scenario, this reference distribution is what we call perfectly symmetric. And what that means is the probabilities on the low side are going to match the probabilities on the high side. And as a result of that, some people will just take the p-value on one side and multiply it by 2. So if you're searching other people's PowerPoint slides, or maybe you've learned that in a statistics class that you took earlier, where you just grab one p-value and then multiply it by 2. Now that only works when you're doing a 50-50 scenario. As soon as you move off of 50-50, this reference distribution no longer is perfectly symmetric. So you cannot use that multiply by 2 rule in those situations. Here's some more questions down here. 3B and 3C, just making a decision here. So that does not meet the 5% threshold. So we don't quite have enough evidence. It's close, but we don't quite have enough evidence. I will let you go ahead and write your conclusion in here, and then click Submit, and you can return back and see your answers to see how well you've done. Okay then, that does it for Stat 110 Module 2 Part 5, our discussion about how to get p-values using a spreadsheet. Thank you very much.